Good afternoon. So here we are. We're going to continue with parallelograms, and this time we're going to go ahead and be a little bit more specific about the parallelogram, and we're going to talk about the properties of rectangles. So by the end of this lesson, you're going to be able to use the properties of rectangles, specifically rectangles, to find missing measurements. And because a lot of it is just like parallelograms, we're going to annotate just like a parallelogram. So you know that you have two sets of parallel sides. So we're going to go ahead and mark up our rectangle that way. We know there's two sides that are parallel. So this side is parallel to this one. And then you got these two parallel to each other. You also know that they're both, you got congruent sides here. So this side is congruent to this side. And this side is congruent to this side. So you've got that. You also have diagonals. So I'm going to go ahead and pause it. I'm going to draw out my diagonals. So that way they look all nice and pretty, because I know some of you can be a little perfectionists. All right. So I've drawn out the diagonals here. So that would lead us to the next part, which is where diagonals bisect each other. So we know that this diagonal is bisected. So you get two equal pieces to one diagonal. And then this one is bisected also. They bisect each other. So we've got diagonals bisecting each other. One thing that's crazy about the angles for a rectangle, and it should be known, is that they're right angles on every vertex. So we're going to remember that you draw a little square in the corners, or you draw a little square period so you know that it's 90 degrees. So all the angles are 90 degrees. All right, so then we're going to go ahead and say, now that we know our angles, we need to remember something else. Consecutive angles are supplementary. So we're going to go ahead and label our vertices. So A, B, C, D. And we're going to know that consecutive angles, remember, one right after the other. So angle A plus angle B is equal to 180. Remember, supplementary means equals 180. So then we also have angle B and C. Angle B plus angle C is 180, because again, they're consecutive and supplementary. And then we're also going to do angle C plus angle D is equal to 180. And angle D plus angle A is equal to 180. And there you have where they're supplementary and they're consecutive. The last detail that we have is that the diagonals are congruent. So we know that DB is one diagonal, and that's going to be congruent to AC. So since they're all congruent, what does that mean for these guys? So we have, not only are they bisected into two equal parts, but they're also congruent. So that means everything about the diagonals in a rectangle is the same. So we can actually change this marking to this is congruent to this, which is congruent to that. And we're going to go ahead and put a point right here, E. So DE is congruent to EB, which is congruent to EC, which is congruent to EA. So all the bisected parts are congruent no matter what. Again, this is for a rectangle. A rectangle. All right, so we're going to go ahead and take a look at sides. The properties are probably the thing that gets everybody all, oh my God. But once you know the properties, then everything else kind of just falls right on out. So we have this side is 8x plus 3, 33, and then this side is 10x minus 6. So we're solving for x. Well, what do we know about these two sides? What do we know? Hopefully you're saying that they're congruent. So this side is congruent to this opposite side. So this is our given. Our unknown is the value of x. I made that a t. No, it's an L, value of x. The equation is going to be our 8x plus 33 is equal to 10x minus 6. Everything has already been substituted, so now we just need to go ahead and solve. So we don't need any substitutions, so everything stays the same. We're going to go ahead and start solving. I always start with the little or the smaller of the x's. So you go ahead and solve and then we'll check. All right. Hopefully you got 39 over 2. If you didn't, go double check yourself. I had to double check myself because I was like, 39, really? No. But then I checked my math and yeah, it's 39. If you catch a mistake that I made or I missed something, please let me know. Shoot me a message because maybe I'm not perfect. I'm only human. So if I made a mistake, but right now I'm getting 39 over 2 and I double checked, triple checked, quadruple checked. Hopefully that's what you got. Yes, we are done because that's our unknown. Our unknown is the value of x, and that's what we already found. So, boom, we are done. Next, we're going to determine if this is a rectangle. So, we're going to have these points. We should graph them. I'm kind of going to graph them, so I'll show you in a little bit. Ta-da! I know some of you, when you first start graphing this and you're only looking at A and B, you're going to sit there and be like, oh my God, I don't think it is. It's the parallelogram. No, make sure you graph out the whole thing. Don't assume anything. Remember, don't assume. Assuming is bad. So, make sure you graph out the whole thing. And right now, you're probably like, well, it is a rectangle. Well, I don't care. You're going to do the distance formula. And we're going to take a trip back in time to the distance formula. So our distance formula, if you remember, is d equals the square root and then x2 minus x1 squared plus y2 minus y1 squared. Make sure you copy that. Okay, so since we have 4 sides, we're going to need to do 4 distances. I know what a drag, but it's got to be done because we need to prove that this is a rectangle. So we're going to go ahead and do the distance of AB first. So remember, we have our points up here. So this should be somewhat of a piece of cake. So don't forget, first thing you got to do is label your points. x1, y1, x2, y2. Make sure you label these out. That way you can't go wrong. You're going to do the same thing for C and D. And since they're going to be a separate formula for this, so we're going to do x1, y1. I'm going to go up here, x2, y2. That way it's not all cramped. Okay. Go ahead and set up the distance formula. We've done this before. Off you go. So now we see that we did the distance for AB, which is the square root of 5. And then the distance for CD is also the square root of 5. So AB is square root of 5 and CD is square root of 5. We can conclude that these two sides are congruent. So what do you think? Do you think AD and BC are congruent? Well, go check it out. Go do the math. All right, so hopefully you got the square root of 29 for each of those two sides. So these two sides are also congruent. Guess what? This looks like a rectangle because the sides, opposite sides, are congruent. Now, the last thing I would have to do is slope to make sure that they're perpendicular. Right now, all I want you to do is focus on finding the distance of these bad boys. After all, we were focusing on finding missing measurements. Slope is for another time. Right now, we're focusing on finding missing measurements. And that's what you did. You found the measurement of the different sides of what looks to be like a rectangle. So we've done all of our finding measurements. Sides, sides. For a diagonal, guess what you're going to have to do? Distance. Oh my, no, please. Well, distance is going to have to happen because you need to see if AC is congruent to DB. So again, you're going to have to figure out, is AC congruent to DB? Yes, you're going to have to do distance. I was letting that sink in. You got to do distance. And we already did distance, so I know you know how to do that. So that concludes the lesson for today. Distance and solving equations. Bam! We are done.